Hannah Wagner. I'm an electrical engineer, and I was responsible for the voltage-controlled oscillators, envelope generators, and the power supply.
Hi, my name is Magdalene Debinda. I'm a computer engineer, and I was responsible for MIDI to CV conversion as well as modeling and cutting our enclosure.
Hi, my name is Seven Van Zant. I'm a computer engineer, and I was responsible for the MIDI to CV conversion, as well as programming the microcontrollers and some of the software stretch goals that we had in place.
Hi, my name is Sebastian Carrion, and I am an electrical engineering major, and I was in charge of the power supply, the voltage-controlled filter, and the voltage-controlled amplifier.
Our senior project is creating a vintage-style monophonic synthesizer that also has digital capabilities. A synthesizer is a music instrument that generates audio signals. The user can use the synthesizer to manipulate pitch, loudness, timbre, and much more, as you will be seeing in the demo. The main goals that we set and measured for our project are that our oscillators must be able to produce sawtooth, square, and triangle waves, our VCF must be able to control cutoff frequency and resonance, our envelope generator must be able to manage all four components of loudness, and our MIDI to CV converter must be able to convert any note on a digital keyboard into an analog note.
Our monophonic synthesizer was comprised of multiple hardware components. These include the MIDI to CV converter, the power supply, VCO, VCF, VCA, and the envelope generator. Our test plan comprised of us working on one of these sections at a time, and we tested that section to see if it was working as intended. For example, for our VCO, we tested to see if we could produce square, sawtooth, and triangle waveforms, as read by an oscilloscope. For the MIDI to CV converter, we tested to see if we get an output voltage from the MIDI keyboard and validated that higher pitches would read higher voltages and lower would read lower, and that each octave would increment 1 volt as read by a multimeter. Once we validated that each individual component was working as intended, we then combined them all with the speaker attached to the end and produced our synthetic musical notes using the MIDI keyboard as our input source.
This is Cynthia, our analog synthesizer. It's grouped by modules. These are our two oscillators. They're the heart of the synthesizer. They actually produce the sound. And here's our filter in the low-pass configuration. We have two envelope generators, which will be demonstrated later, one for the filter, one for the amplifier. Here's our amplifier, and each module can be modulated by the low-frequency oscillator. As seen here, our synth is controlled by MIDI, so you can play either yourself through a keyboard or through a computer using predefined MIDI notes. These are our oscillators, VCO1 and VCO2. They're both identical. These two knobs are for adjusting the frequency or pitch that you hear, coarse and fine, with volume adjustment, and 3 wave types for the wave selection. So right now you're hearing a saw wave. You can also use a square wave and adjust the pulse width. Or a triangle wave. And add another oscillator. This is our low-pass filter. You can change the cutoff frequency, lower it to create more muffled sounds, or increase it to brighten your sound, and add resonance to create more sweeping sounds. The envelope knob allows you to control the amount that envelope generator 1 is modulating the filter, so turning it all the way up. You can adjust the attack, decay, sustain, and release parameters. This is our second envelope generator for our amplifier, allowing you to control the amplitude of the sound to create more plucky notes, like you're hearing now, or more legato notes.
During the process of creating our synthesizer, our group found it really easy to collaborate on this project because so many components of the synthesizer could be created and tested on a standalone breadboard before putting all the pieces together. And staying motivated throughout the entire project came really easy to us throughout both semesters because we were all generally really passionate about the topic of music, and we were new to the topic of synthesizers, and there was such a big community and it was such a big topic that seeing the project come to life was really rewarding throughout the entire process.
So initially, one of the challenges that our team faced during planning and how we overcame it, an example of this could be the power supply. Our power supply initially lacked proper overvoltage protection, and while prototyping this power supply, we noticed that components such as the op amp and the capacitors exceeded their maximum voltage rating. We were the primary stakeholders, so we tried to reduce costs by building some of the hardware ourselves. An example of this could be the MIDI to CV. We programmed an AT Tiny, and this cost us about $20 more or less versus a module which could have been bought online for $200. And another example of cutting costs is building the enclosure ourselves for the synthesizer, which we made out of acrylic, and which the total cost came out about more or less $30.
I think the biggest lesson that we learned throughout this process is that regardless of the results or outcome, the most important part of a project is your team dynamics and making sure that every member of your team is happy with the role that they were given. Checking in and communicating on a weekly basis is really important for a team, and I think it's something that we're going to take away both in our workplace and our day-to-day life. Our biggest motivation for choosing this type of project is that it required bridging together so many concepts that we learned in our course load at UCF, as well as learning fundamental music concepts and incorporating them together. We really just wanted to challenge ourselves as engineers and deliver a product that was initially really expensive on regular marketplace. We finally did it. Our project is finished and we could not be more proud of it. And we want to thank you so much for watching and including us in your showcase.